Hello, Spindler Academy. So today we're going to be talking about standard deviation and how to use it, or what it is. And there's going to be a bit of this video that I don't fully understand, but we're just going to work through it. And if I do get it fully later on, I'll make another video about it. So let's just get started. What is standard deviation? Standard deviation is defined as the square root of the variance. And that begs the question of what is the variance? So the variance is defined as the average of the squared differences from the mean. So we know what the average is, we know what the mean is, we know it's mu, at least that's what I said in the last video, and we know what squared differences means. So I want to talk a bit about how mean can mean, sorry, English is weird, but how the mean can mean different things. So when you're talking about a population, I'm going to highlight this area right here. When you're talking about a population, the mean, you refer to that as mu. If you're talking about a sample mean, you refer to that as x bar, and that's what this symbol is. So that begs the question of what is population and what is a sample. A population is when you're referring to all of the elements from a set of data, or it refers to everything in your data. A sample is a subset of the population. So a sample is like what you collect compared to what's the actual, what you're trying to get at. So the sample is usually less than or a subset of the population. And when you're referring to the population, like if you're referring to mu right here, then that mu would be a parameter, whereas x bar would be a statistic. And so we know that, well, I said that the variance was defined as, or the standard deviation is defined as the square root of the variance. So we know that the variance is sigma squared, or s squared. And if you take the square root of something squared, then you just get the standard deviation, which is sigma, or the standard deviation for the sample, which is population. Or sorry, which is s. Oh my gosh. Okay, the population standard deviation is sigma, whereas the sample standard deviation is s. Okay, so now we can actually get into finding, oh my gosh, I forgot to remove these. Well, okay, we can see if they're right, but I filmed this once before, and it didn't go well, but only because I was having problems with the calculator and whatnot, so that was already there, but just pretend you didn't see it. So the population variance, we're going to try and calculate for the same set of data that I used in the previous couple examples, or previous couple videos. So we know that we know that the mean mu, whoops, that looked awful, mu equals 6. And we could find that by just going 1. I've already found it twice in the previous videos, but let's just assume it's 6. Actually, I guess I should double check, but well, yeah, it's 6. Okay. So then we want to find the variance. So to do that, we go 1 minus 6, then we square that, plus 2 minus 6 squared, plus 2 minus 6 squared, plus 4 minus 6 squared, plus 6 minus 6 squared, plus 7 minus 6 squared, plus 20 minus 6 squared. And we take all that over 7. So to find that, and I have a calculator here, I'm going to turn it on, and the buttons are a little off, so if you see me hitting like under it, that's intentional. So 1 minus 6, well that's 5 obviously, so I can do most of these in my head. So we get 5 squared is 25, plus 4 squared is 16, negative 4 squared is 16, plus 16, plus 2 squared is 4, plus 0, plus 1, plus 20 minus 6 is 14, 14 squared, I don't know, 14 squared, 196. 96. And all that over 7. So 25 plus 16 plus, well, plus 16 plus 4 plus 1 plus 196 equals 258. Over 7 equals 36.857. Then we do the square root of that. And it's going to be almost 6. Oh, I can't do that on this calculator for one of the problems, but there's the actual calculations of 6.07. I already did it. So 6.07. So, well, dropped my tablet. So that's the standard deviation sigma, and 36 is the variance. So if I wanted to put those into the calculator and calculate it another way, let's go 1, enter, 2, enter, nope. Enter, 4, enter, 6, enter, 7, enter, 20, enter. Then you can go second, calc, no, stat, calc, one variable stats. We're going to use L1, we're going to calculate it. Then you notice that we get a sigma, the same as what we just calculated, 6.07, which is this value right here. So then why does, and just to show you what this is, it shows you x bar, it shows you the sum is 42, it shows you the sum squared. Just ignore the, or not, don't ignore, but I'm going to talk about this in a second. Sigma is 6.07, which we calculated here. The number of elements is 7. And then it gives you the 5 number summary too. So 1, Q2, Q1, median, Q3, and max. So what is the difference between S and sigma? Well, the difference is how you calculate it. So you use n-1 if you're talking about the sample, and you use n if you're using the population. And this is the part that I don't fully understand. But just know that there's a difference, and yeah, I guess that's it for now. If I do fully get why you use n-1, I'll make another video about it. But other than that, thanks for watching. Bye.